Lewis dot structures can be used to determine the shape of molecules.
Bonds, whether single, double, or triple, and lone electron pairs, that is, electron pairs on an atom that are not part of a bond, arrange themselves so as to be as far from each other as possible. If a central atom has only two bonds and no lone electron pairs, these bonds can position themselves opposite one another, with an angle of 180 degrees between them. This molecular geometry is called linear. An example of a linear molecule is carbon dioxide. Carbon does not have any lone electron pairs in carbon dioxide. If a central atom has three bonds and no lone electron pairs, in order to be as far from each other as possible, the bonds must point towards the vertices of an equilateral triangle at angles of 120 degrees to each other. This molecular geometry is called trigonal planar. An example of a trigonal planar molecule is boron trihydride. If a central atom has four bonds and no lone electron pairs, to be as far away from each other as possible, the bonds must point towards apices of a triangular pyramid at angles of 109.5 degrees to each other. This molecular geometry is called tetrahedral, and an example of a tetrahedral molecule is methane, CH4. If the central atom has lone electron pairs, these pairs need to be accounted for when deducing the molecular geometry. Lone electron pairs need to be positioned as far as possible from bonds and from each other. For example, if a central atom in a molecule has three bonds and, in addition, one lone electron pair, then the bonds and the lone electron pair must point towards the apices of a triangular pyramid to get away from each other as far as possible. Therefore, the three bonds are not in the same plane. The angles between them are 109.5 degrees, like in the tetrahedral geometry. But there is no fourth bond. Instead, there is a lone electron pair. This geometry is known as trigonal pyramidal. An example of a trigonal pyramidal molecule is ammonia, NH3. If a central atom in a molecule has two bonds and two lone electron pairs, then the bonds and the lone electron pairs point towards the apices of a triangular pyramid. Therefore, the two bonds are not opposite each other, but again at an angle of 109.5 degrees. This geometry is known as bent, and an example of a bent molecule is water. The following slide summarizes the various possibilities for molecular geometry.